Bingo. We are recording. Here we are on May 19th. We're with the SMPTE group from New England. And thank you, Karl, for being with us. Marty, open the meeting, please.
Paul. I'm Marty Feldman. I'm section chair of the New England section. And a little bit of business now before we start the meeting. And of course, I do want to welcome Karl. Karl's an old friend of SMPTE and an old friend of all of ours. He has been, he's currently with Telestream, which Telestream and Tektronix now are all together. And he was with Tektronix for 2000 and did many presentations, technical presentations, both for us and directly for Tektronix. I've been to many of them, and they're always outstanding.
Thank you.
He's really a major explainer of technical material. Truly if you're just learning it, it's a good way to learn it. He just does such a fine job. And I've saved many of his presentations and I go back to them all the time. So you're in for a treat tonight because he's going to be covering the transition of SDI to IP. And that would include ST2110, which is all about digital video over multiple streams. And also ST2059, which is all about the timing, which was derived from IEEE 1588. And should be a very interesting presentation where, we're being dragged into IP one way or the other. So, it's, I've been through all of the battles, all the way from when you carried analog sync over 6 cables. So it's a changed world. There's no question about it. All computer driven. A couple of things I wanted to bring up. Apparently, we got a notice through Jason Clifford, one of our managers, that there is a broadcast engineering opening at WBZ. That's the CBS outlet here in Boston. And they're looking for an engineer to maintain, install, operate technical equipment. And if you're interested in this, you contact Emily Friedberg at the station. And let's see if I've got actually, I don't have her email, but if you contact me, I will get it for you. I thought it was here, but it is not here. But if you get in touch with WBZ CBS, you should be able to get her there. She's Director of Talent Acquisition at Viacom CBS. Does anyone have any knowledge of any job openings? I'd like to kind of open this up and see if anyone, we can share this information and help anyone that's looking for work. No one right now. Hello, Brian. It's good to see you. How are things in Southern Connecticut? Oh, no sound, no audio. There you go. No audio.
There we go.
No
Southeastern Connecticut is happening. It's all good. Karl, good to see you again.
I also want to congratulate our newly elected managers and also treasurer, Paul. And most of these have served before, sometimes immediately before. So, but we have, of course, Dave Acker, who is here tonight, and Jason Clifford and Bob Lamb, who's been with us forever. Bob is our webmaster. So I definitely want to thank them for staying on and helping. We can't do it alone. It really takes a village running this. So I want to get on tonight with the presentation, and I'll admit I have a tremendous amount to learn about this transition from SDI to IP. IP is very new to me. I have been dragged into it, but I'm learning it, and it's not as bad as I thought. So to give us the details, I'll turn it over to Captain Karl.
Thank you, Marty. Thank you, Paul. And thank you for everyone taking time out of your busy evening to hear what we have to say, because as Marty said, things are changing fast. In fact, like many of you have been involved with this industry for many, many years and seen many, many changes. And the changes that I'm seeing in the last 4 or 5 years are some of the biggest changes I've seen in my entire career. With that said, if you unless you're looking at retirement like right now, you probably want to stay current. Even if you are retired, it's good, it's fun to stay current. But the changes that are happening now are big. And with that said, there's a lot to learn. So what I'm planning on sharing, hopefully my screen share works well here. Hopefully you can see my screen. If somebody would say yes or no, that would be great.
Yes.
Okay, great. So what I'm sharing with you this evening is a presentation that I've learned in my travels for the last 4 or 5 years of being involved with greenfield builds, hybrid facilities. But essentially, it's all about the lessons learned and best practices, because 4 or 5 years ago, there were no best practices. There weren't any lessons learned because we were making it up one day at a time as we went along, which means a lot of mistakes were made. So what I'm really trying to share with you this evening are questions to ask that the early adopters wish they would have asked, but they didn't know. And that meant a lot of complication and missed schedules and just the challenges of saying we're going headfirst in new technology when you realize you're the early adopter. And on the bleeding edge of technology, that's exciting, it's fun, but it also can be a little tough at times because you're trying to figure out how to make things work. I actually had a system integrator say for the first time in their career, they actually walked out of a project one evening and said, I don't know if we'll ever get this to work. It was that frustrating at that time, but like anything else, you put enough smart people together that are dedicated to making something happen, and it worked. And we've all learned from that. So what I'm planning on doing this evening is sharing with you some questions to ask as you make the transition from SDI to the world of IP. One of the fundamental things to realize is that through SDI, I mean, SDI has been around for decades. I mean, it's been around, it's been proven, it's figured out by everyone. We know how to make it work. And SDI out goes to in, and you're doing video. Thing to keep in mind, there's always a delay in the world of electronics. Through SDI, your coax, it's fundamentally, it's the speed of light, but the speed of light is only the speed of light through air in a vacuum. The speed of light through something solid like optical or copper is a percentage of the speed of light. So depending on what cable type you're using, pick your favorite cable, there is a different propagation delay in all your cables, but it's consistent. The speed of light doesn't change from second to second or from day to day through a piece of coax. If you have any frequency instabilities, it's at the physical layer, the electronic layer, which means if everything is good, you bought high quality equipment and the fans are working and everything's properly grounded, you should have a stable signal. But keep in mind with SDI, everything was pretty much a home run. From device to device, signal to signal, you had cable for your timing, cabling for your video, cabling for your audio, cabling for intercom. But now through the wonders of IP, we can share a connection through many different facets as far as through fiber optics. So what we're doing here, you have jitter now introduced because the wonder of IP is instead of having home run individual dedicated connections between devices, you actually are sharing the pipe with your various elements of your video production. You're sharing the same pipe, the same piece of fiber with your video, your audio, your system timing, and intercom. And that's a wonderful thing. There is a huge savings by doing that because your physical plant is much more simple. You have a 10 gig, a 25 gig, a 100 gig pipe, and that can carry all kinds of traffic. You're not relying on individual connections. And this was one of the big reasons the early adopters that I worked with were the OB truck people. You know, up in New Hampshire, you have Game Creek, Pennsylvania, Pittsburgh area, you have NEP, and a few smaller ones. But they really jumped on IP because their business model is to tell a story, whether it's a rock concert or a big football game or some kind of an awards ceremony. It's all about telling a story. But they're in a mobile business, which means they have 18-wheelers running up and down the interstates all across the country and all over North America. They do not get paid to carry coax because coax is heavy. So what they determined, they could save weight, because the challenge in the OB industry is they're always up in the US 80,000-pound weight limit. That's as much as a truck can weigh going across the interstate highway system. So if they're over, they get fined, or they actually get the out of service notifications, and they have to take weight off the truck. Well, by getting rid of copper, they got rid of a lot of weight, which meant they could add technology to the truck to actually tell a better story. Because when 50 cameras aren't enough, somebody wants 60 cameras. So you always need to be adding more stuff to tell the story that the customer wants to pay for. So what happened was they adopted it early, which freed up, because also space is a big deal in a truck because they're double expandos. They're huge, but there's only so much space. So it's a weight and space savings. So that's one of the big reasons they jumped on IP. Also, major greenfield facilities that were SDI, they said, well, now is the time that we move to IP. Well, there's many challenges with what they did. First, let's talk about the standards, get that out of the way. Don't want to talk too much about it. I want to more or less focus on the practical aspects of the implementation. So we had good old-fashioned SDI that was put into SMPTE 2022-6. That is SDI, good old-fashioned HD, SDI, for example, cut into packets and put into an IP packet. So the hank, the vank, the audio, the video, the ancillary data was just chopped into chunks and thrown into a packet. That was the earliest implementation of IP. We're talking about IP in the uncompressed domain. Compressed video has been around over IP for 20 years or more. Well, that's not live production uncompressed. We're focusing on live production uncompressed. Okay, so SDI encapsulated in IP was SMPTE 2022-6. For IP audio, AES 67, that's been around for a while. But the real challenge is IEEE 1588, which is how we get SMPTE 2059 precision time protocol. How do we time a system in the new IP world? Let's face it, Blackburst, Genlock, tri-level sync has been around forever. It's incredibly dependable. It's so dependable, so well understood. Now's a perfect time to get rid of it and do something much more complicated. Well, here it is, SMPTE 2059 PTP, Precision Time Protocol. They had people say, why can't we just time our system with NTP, Network Time Protocol? That's as accurate as SMPTE time code. We need precision. NTP is a software implementation. PTP, Precision Time Protocol, to get the precision, is a hardware-based implementation. Okay, so 1588, IEEE 1588 has been around for decades. Every cell phone call you've ever made, banking transition, financial industry is based on IEEE 1588 Precision Time Protocol. Automotive assembly plants, automotive robotic manufacturing facilities are based on PTP, IEEE 1588. What happens in 1588? Timing information is roughly sent every 1 second up to every 2 seconds. And that's enough to do cell phones and finance and robotics. But we're special. We all know that we're special. We're doing video. So we need something far more accurate. So what was done by the standards group SMPTE, which we're all a part of here, is coming up with a version of IEEE 1588 that meets the needs for video. Because in video, we're aligning packets, roughly 4 packets per line of high definition video that need to be time correlated. So that way you can have seamless switching between feeds. So 1588 was not accurate enough. So 2059 sends information up to 8 times per second, which is a whole lot different than every 2 seconds. So 8 times a second is what you need as far as accuracy to lock a video signal. Very important aspect. We'll drill into that a whole lot deeper. SMPTE 2022-7. This is taking 2022-6 and making it, you have a primary and a backup for seamless switching between your primary and backup. It works wonders. It's great for, transmitting something over a distance where you want to make sure it gets there. If it doesn't, you have a backup plan. Let's jump all the way down to the bottom where we're going to spend most of the rest of the evening here, is on SMPTE 2110. SMPTE 2110 is taking SDI and tearing it all apart, where 2022-6 was taking it and just chopping it into packets, where 2110 is taking all your elements of your SDI signal and breaking them apart. Video has its own stream. Audio has its own stream. Timing has its own stream. Ancillary data, closed captioning, and so forth is its own stream. So it is actually individual packets that are dedicated to audio, video, timing, and ancillary data. The beauty of that is when you're processing your signal, unlike 2022-6, where it's SDI encapsulated, every time you want to sweeten the audio or do video graphics, you have to de-encapsulate it, do your processing, and put it back into an encapsulated 2022-6 stream. So that way it looks like SDI back in a packet. So what was realized very quickly in live video, that's all you're ever doing is de-encapsulating it, processing it, putting it back in. So there's a lot of lifting required to make that happen. When you tear something apart, it doesn't always go back the way you thought it would. So with SMPTE 2110, everything is torn apart, which in live video production is very handy because the video goes where the video needs to go, the audio goes where the audio needs to go, and so forth. That way, at the end, when you're ready to put everything back together, you use precision time protocol timestamps to time reference and put all the parts back together. So that's a beautiful thing about SMPTE 2110. The beauty is the flexibility. The complexity is actually making it work and testing it. Well, with SMPTE 2110, we finally get rid of blanking. And Karl Paulson had a conversation with him, the CTO of Diversified, and he was saying, this is big. And I go, I'm not getting the point. He said, by getting rid of the blanking, the hank and the vank, your blanking interval, it doesn't matter what size your active video is, because you're no longer forklift upgrading every time there's any kind of a format change, because SMPTE 2110 can actually have a resolution of 32K by 32K. Why would you ever need that? Well, how about the ribbon around the stadium? You don't need 32K of vertical, but horizontal, that would be really cool. So it frees you from being constrained by your aspect ratio, your frame rates, your resolution in general. So there's a lot of flexibility now and in the future. And with today's world where things are being repurposed for who knows what different reasons, it's good to know that you have some freedom now and freedom in the future. Let's talk about precision time protocol. This is where, in all reality, folks, this is where you'll be spending the rest of your career making something work and understanding it. So whatever you can do now, I would highly recommend you start studying 2059 if you haven't already. If you have, you can't know too much. But what it's all about, once again, is replacing our good friend Genlock, because once again, Genlock's too dependable, gotta go. So precision time protocol is all about how do we time a system bidirectionally with packets with very accurate GPS reference timestamps put in it. Well, the challenge there is we need a best master clock algorithm, BMCA. Best master clock algorithm is the PTP equivalent of a changeover unit. In the Blackburst Genlock days, you have an ECO, a changeover unit, which says, here's my primary. If that fails, it seamlessly, hopefully seamlessly switches over your house reference to the backup unit. Where PTP, that is baked into the standard. The best master clock algorithm is an automatic way that the system recognizes which time source. There we have two SPG 8000As, that's the Telestream piece of hardware that creates your timing signals, Blackburst, tri-level sync, and also precision time protocol. And the beauty of that is they're both in the same box. So if you have a GPS lock on both, you have a primary and a backup, your configuration decision is, if everything is equal, which one of those is controlling my network? Sending out timestamps to the network that they lock to, and the network then sends a timestamps back up the network for the grandmaster to look at to see how the network is behaving. So you have a best master clock algorithm that determines automatically which unit is worthy of actually running the network. Let's say the one on the left loses GPS lock. Well, the one on the right has GPS lock, so there's a constant voting process going on that determines which time source is the most accurate. So one is locked to GPS compared to one that's now free running. Well, that no longer is worthy of running the entire system. One of the things to remember, one of the dangers, it's can't really get into it that much in this 40-some minutes I'm going to be presenting, but there's a lot of configuration issues to determine which one, if everything is equal, is in charge. If something is not equal, which one steps in, and there's a pecking order. But you want to make sure that your clocks that are further down the network, that should never be a grandmaster clock, don't step in and say, well, it looks like I'm in charge here. Okay, network, listen to me. Which that is nice that somebody steps in and volunteers, but that device is probably not worthy of running your entire network. If it's a clock inside of a switch, it's not referenced to GPS, so you should have something more accurate actually timing your facility. So what is happening? You have announce messages that are going out to the network saying, listen to me, I'm in charge here. And if they go away, then the voting process, that's another way for the voting process to take over. So your best master clock algorithm determines which grandmaster is the best. Because keep in mind, one of the things I'm going to mention in the best practices here is a boundary switch. This was not really realized in the early days, 4, 5, 6 years ago, as far as the value of a boundary switch. Because let's face it, you have a grandmaster, let's say a top one, SPG 8000A on the top left, is blasting out 4 times, 8 times a second timing information that propagates through the network, and all your edge devices say, thank you very much. Here's what time I think it is. So there's a back and forth until the oscillations zero out, that everything is locked. Because what should happen in a properly configured PTP system, you hook up a device, it should lock in 5 seconds to be time accurate with the rest of the facility as far as PTP. If it doesn't lock in 5 seconds, it will probably be a whole lot longer than 5 seconds because something is wrong. So what you want to do, what the boundary switches, acting as a PTP distribution app, acting as a DA. Very important concept, which was not really implemented in the early days because people didn't really fully realize that they needed it. What that does, because you have a grandmaster that's talking to thousands of devices, that's a whole lot of traffic going up and down your network. How do you what you're trying to do in the world of IP is reduce traffic, not figure out ways to make more traffic. Because video is gigabits, audio is megabits, PTP is kilobits, but the PTP kilobits is the most important time information that must flow up and down the network smoothly. You're going to be very tired of me saying the word smooth real soon, because smoothness is the entire challenge of this entire move to IP. Because what you need are a smooth network with your data flowing up and down with timing information. So what was decided, your boundary switch, which could be a Cisco, Arista, your favorite vendor, needs to have a boundary clock built into it, PTP aware. Boundary clock means that it will isolate the grandmaster from having to deal with all the requests for time further down the network. So that way the boundary clock is communicating with your grandmaster, and the grandmaster is only communicating with boundary switches. So the boundary switches take over the task of communicating with all the edge devices 4 to 8 times per second. But thing to keep in mind, one of the questions people didn't realize in the early days, that is a hardware option you pay good money for, to have a PTP aware boundary clock capable switch that can do multicast joins, because multicast joins are how PTP actually happens. So with what we're trying to do here is reduce workload from the grandmaster. So what you need to have is a switch that is PTP aware. What does PTP aware mean? PTP aware means that the boundary switch realizes a quality of service determination that your PTP, your little kilobit packets, are the most important packet it has to prioritize in and out of the switch. Which means when PTP packet shows up, it says, okay, megabits audio, gigabits video, step aside. The PTP's got to come through as fast as I possibly can because the whole network stability is counting on that happening. Once again, that is a hardware option you have to pay extra for the ability for the switch to prioritize its PTP high priority content. Okay, so lessons learned in a new world order. Continuous learning. Well, folks, you're doing it here tonight, and it's something you need to be doing every day or you're becoming obsolete by the day. Well, we can't afford to become obsolete, and being obsolete is not that much fun. So continuous learning. So getting involved with SMPTE, I think I'm preaching to the people who understand this, but one of the value propositions I always give, being involved in professional organizations at a minimum forces you to put a date on a calendar, to learn something new and meet someone new. In today's world, you can't be doing too much of any of that. So meeting somebody new and learning something new is how you stay current. You get to hear what the rest of the world is doing. You get out of your bubble and actually learn what's going on. And people might have answers you don't have an answer to. Be active professional associations. What I've learned in my short life here, that the more you give, the more things come back to you in unexpected dividends. Because I was a SMPTE denier for probably half of my career. I always had excuses. I got, kids in diapers. I got bedrooms to paint, lawns to mow. And eventually, because I was a lab engineer in Bethesda, Maryland, and the guy that I ended up replacing at Tektronix said, you got to get out of your IBM bubble and see what the rest of the world is doing. So I finally went to a SMPTE meeting and I realized I didn't know what people were talking about. And I've been involved in video since the early 70s in 9th grade. So I said, that was intimidating, but I got to jump in with both feet and it's a slippery slope. So here I am today. Get involved. Configuration is everything. In the world of SDI, as I said, out goes to in and you're doing video. Well, in IP, nothing happens unless everything is configured. And that means configured every drop down, every radio button, every fill in the blank must be correct or it doesn't work. Or what's even worse, it can actually impact the entire network with one device not being properly configured. Just for example, IP conflicts. You have two devices with the same IP address. Well, that's never a good thing. Configuration is everything. You can't guess. An IP device that's not configured does nothing. Or an SDI device, you power it up and you can probably put video and get video out of it with some minor configuration. Of course, there's a control port that you want to access it remotely, but IP, everything is about configuration, and everything about configuration usually means human error creeps into it with configuration. Small form factor pluggable, SFP matching. In the early days, we ran into situations we can't get the signal to go from point A to point B. And let's start with the physical layer. Look at that. You have a 1310 nanometer SFP on one end and an 850 nanometer on the other end of the same piece of fiber. It's never going to work. Well, that was proven. So you change one to the other and match them up on both ends, and it's working. You need to make sure, because SFPs are small, about the size of your pinky maybe, but roughly what you have to do is look it up on the web, because sometimes it's hard to even read the model number, the serial number, whatever data is actually in the SFP, and do a data sheet of it so you really know what you have to make sure it's what you think it is. Also, I tend to defer to your switch manufacturer. There's smart people at Arista, Cisco, and so forth. What do they recommend as far as what you use for SFPs? Because when push comes to shove, and you're using something you got cheap off of Amazon, they're going to say, that's an unsupported SFP, replace that, then we'll talk about your technical problem we're trying to solve. So you don't want to throw in unknown. So SFP matching, defer to your switch vendor as far as what they think you should be using, and do it. Fiber cleanliness. Let's face it, BNC connectors, you can drag them through a mud puddle and hook them up. They'll probably work. Well, it doesn't work that way with fiber. It's all about grease, lint, dirt in general. Needs to be clean or else the signal doesn't pass through. No patch panels. Realize this in the early days, because I'm sure at least once in your career you had a problem in a facility. Let's cut the facility in half at the patch panel, patch around it, patch through it, and you start doing troubleshooting that way with the patch panel. There is no such thing in the world of IP. You don't pull out an SFP from this port and put it over here and see what happens. Well, a whole lot of things are going to happen because there might be 25 gig of content on that one connection. So you have to get into the methodology, the mentality, the philosophy of really realizing how to use test equipment, because that's all you have for visualization. Redundancy. We like redundancy. We're in video. How much redundancy can you afford? How much redundancy do you have space for? The OB trucks run really light on redundancy because weight is their biggest problem, 80,000 pounds. So you don't want to have any more stuff in the truck than you have to. Some facilities are actually saying we're going to have 2 different pieces of real estate running 2 different vendors' hardware in case a virus breaks out. We won't be consumed at both facilities. Well, that's kind of an extreme case, but it's a business case. As I said before, the word smooth, you'll be tired of it. Why? Because data networks are not smooth. Data networks have never been smooth. Data networks have no reason to be smooth because data is bursty. You upload, you download, and you wait. Upload, download, download again. It's bursty traffic. We're doing audio and video and precision time protocol. There's nothing bursty about it. It never stops. 4 packets per line of video just for the video portion of what we're talking about here. That's gigabits. Data networks are not smooth. As far as data people with no broadcast experience coming into the industry, if you can picture that, but it's happening, they have no real concept of smoothness. My oldest son is a cybersecurity expert, and he has no reason to ever worry about how smooth his network is. If everybody gets the content, doesn't complain, his job is done. If it takes 3 seconds, 10 seconds, or whatever to upload or download something, that's the way it goes. Because in data networks, it is bursty. We need a rock solid, smooth, and stable network. That is the goal. That is the challenge. And we're talking to your heavy duty IT people, the people that are worried about the cybersecurity, the backbone, the 100 gig stuff. Smoothness is what you need to stress, which in data networks, they never had to worry about. IP layer. IP adds another layer of abstraction. What does that mean? Well, the good old days of analog, remember taking out your greenie tweaker and clockwise, counterclockwise, better, worse, better, worse. Well, better's what I want to do. You pull out your greenie tweaker and you've tweaked the system. Because back in the good old days of analog, your system, your actual electrical layer was directly correlated to what you were seeing as the quality of experience. So the quality of service, the actual electrical signal, directly correlated to the quality of experience, what your eyes and ears were experiencing. Then we went to the digital world of SDI. We brought in a cliff effect. Now we've added another layer of abstraction called IP. It's kind of like your car. When I was a gearhead in my younger days working on cars built in the 60s and 70s, it was an analog device with some basic tools and a few meters and a vacuum gauge. I could pretty much do anything to a car. Those days are gone. Cars have dozens, if not dozens and dozens of computers all multiplexed together over CAN buses and whatnot. You need instruments to see the layers of abstraction of what's actually happening. Without codes, I mean, most technicians and mechanics wouldn't know where to start. So it's all about the sensors and the codes. It's the same thing in the world of IP. Switches must be multicast, join capable, and PTP aware. And both of those you have to ask for. Because once again, SMPTE 2059 requires PTP to be aware as far as the switches with the quality of service. On a small network, you can get away with anything. But we're not in the business of building small networks. We're in the business of building rock solid, resilient, big networks. Okay. Stream captures are priceless. Oh, yeah. So you have your test equipment. Somebody want to hit mute? Dave, you hit mute, please. Stream captures are priceless. So what we do there, the Prism that we'll talk about here later in the presentation, you can actually do a screen capture to see what's happening on the screen and a stream capture for doing analysis actually of the 1s and 0 levels. Without this, how else do you go to a vendor and say, I narrowed the problem down to your black box, coming in good, leaving your black box no good? Well, we troubleshot to that level. Now, how do we get to the nitty gritty, what's happening inside of your black box? So stream captures are priceless, instantly gets the respect of a vendor because you know what you're talking about. When in doubt, boundary clock. If you remember anything out of my spiel here tonight, when in doubt, boundary clock, as far as that gives you the isolation of the grandmaster from all your thousands of devices in the field, and it reduces your traffic up and down the network, where your boundary clock acts as a DA. System integrator is the key to your project success. Once again, system integrator is the key to your project success. The days of DIY, do it yourself, in reality, I would suggest are over, because you would not have the experience in-house to do this. I've done shows, NAB, you name all the good shows, we did shows, and I've actually had people asking a lot of good questions, and I'd say, what system integrator are you using? Oh, we don't do that. We have sharp people in-house. I would say, I don't think you want to do that anymore. If you have a big budget and lots of time and no real deadline, go for it. But I would recommend at least building a lab. We'll get into that. Learn Wireshark, free utility you can download off the web. And it's handy. It's not doesn't do what I'm showing you as far as the Telestream solution, but it's just another tool in your toolbox, and it's free, so why not become familiar with it? Test equipment is your friend, because you can only reboot your way to success so many times. Jump ahead, fall back as far as firmware versions, then you're done. What do you do next? You need test equipment to look in, to ask all the right questions, to help you visualize where things are good, where things are not good, so you can actually have an intelligent conversation. Keep a library of all pertinent standards, because vendors will be throwing the standards around, and it's good to know what the heck they're talking about, because standards are what this is all about. Also, what to be aware of, you can have all these vendors saying they follow the standard, but it's their interpretation of the standards where the interoperability falls apart on a system. In the early days, there's a whole lot of that because, oh, we didn't interpret the standard that way. Well, you're the only vendor that doesn't in this entire building. So maybe you want to revisit that. Yes, you're correct, but nobody else is implementing it that way. So its interpretation of the standards is how we get interoperability. Maintain a book of knowledge. A good thing to do because you have a problem, write it down. What the symptoms were, what your philosophy, what your process was, your methodology for getting the answer. Then what fixed it? And how did you know it was fixed? So good thing to write that down because maybe you'll never see it again, or maybe it'll happen, on another shift when the person that figured it out last time is not around. Okay. Where to get started? You need a sandbox for your entire facility life cycle. I stressed this in the beginning, and it warms my heart when I have customers say, Carl, we listened to what you said, and we have a sandbox, which means that is a safe place to experiment before you hook something up to a live network. It's a safe place to figure out what the heck you're doing. It's a place to learn. And this is for the entire life cycle of your facility until somebody says we're shutting this place down and doing something totally different. You need a sandbox. Because the days are over of just taking something out of the box, hooking it up, video in, video out, and you're doing video. Gone. You need some way to power something up, do all the configurations based on your standards and conventions of how you have everything else configured, hook it up, and see what happens. If it behaves like everything else in the network, congratulations. If it doesn't, don't hook it up to the live network until you can feel safe that it behaves as it should in the rest of the network. So the suggestion I've made that people have actually followed is you buy an SPG 8000A. That's the Telestream Tektronix video signal generator, lock the GPS that creates black burst, tri-level sync, and PTP. Then on the other end of your magic system you're building, you have a Prism, which is a waveform monitor that does SDI and IP and PTP. Then you build your network between those two devices and you keep building it and see how it behaves. So when you have a new device you want to introduce to your network, you take it to the lab, your sandbox, and say, okay, let's configure it. Let's see how it behaves. And then you hook it up to the network, cross your fingers, and I wouldn't do it. I do it at 2:30 in the morning or something like that and see what happens. It can do nothing, or it could actually impact your entire facility, or it will work like everybody said it would. You need to justify test equipment in business terms. I came up with this presentation because I learned things the hard way. Everything is a spreadsheet. Everything is return on investment. Everything is a business model. Right before I quit IBM back in 2000 and came to Tektronix, I was an R&D lab. I was responsible for buying test equipment, lots of test equipment. Like one year I bought $700,000 worth of just Tektronix test equipment. So I was known as a good customer. So anyway, that was the challenge of hiring me because they hired a good customer, which means the big spender was now working for them. Okay, so what happened was in the early days, like the late 90s, I would say it changed. I used to be able to go into a meeting and say, here's what I need for this phase of the project. We're deploying something in China, wherever it was at the time. And for each phase of the project, what I need for test equipment, what I need in the lab, what we need in the facility operationally, and what we need for people running around in the field. That was my job. And I would present this and everybody says, okay, fine. Okay, next person present, and you go from there. Then one day in the 97, 98, an executive that I never met said, okay, Karl, what's my return on investment for what you're proposing? I had no idea what they were talking about. I was a lab rat back then, had no idea return on investment went because nobody ever talked like that. He says, you don't get what I'm saying. I give you $1, I need $2 back in 18 months. Tell me how that happens. I had no idea. So what I've learned the hard way is test equipment is cheaper than having your facility be in chaos all the time with overtime, problems, going off the air, customers leaving because you can't deliver quality. It goes on and on and on. Test equipment is always cheaper than not having test equipment. You can't guess your way to success anymore. So you need to justify test equipment in business terms. I have a 15-minute presentation that I created that I do it for some events and some organizations. And some people told me it's the best presentation they ever heard because they realized their entire career they were going about things wrong. As technical people, we're not that good at speaking to business people. But unfortunately, business people hold the money, which is all the fun that we need to get our jobs done. So when I hear a customer say, Karl, this is great about test equipment, but there's never any money for test equipment. It gets cut out of the budget and never even makes it in. I go, we need to talk. It needs to be presented as a business case. And all of a sudden, business people say, I hear what you're saying. And then the conversation grows from there. Every drop down, every radio button, every fill in the blank must be correct. Finger pointing, maybe you've read about it on the interweb, maybe you've done it in the past, but don't want to admit it, but finger pointing is a lot of fun until the fingers all point back to you and everybody shrugs their shoulders saying, well, I don't know. Well, we can't afford to do that. That is a waste of time. I've been involved with some finger pointing episodes that went on for weeks. You come in with a prism, an analyzer, and say, here's what the problem is, and here's where it isn't. So I think it's here that we need to drill. Finger pointing is a waste of time. It's rampant because there's so many unknowns in this new world that we're going to. So it's easy to say, can't be me. It must be somebody else. Well, that's not a good way to run a facility. Once again, you need to drill into the abstraction layers that we're dealing with a multi-layer architecture. Because what we're dealing with now in the world of the ISO 7-layer stack, we need to be able to look at all the layers, make sure everything's performing. An intensive care ward, I like to use medical analogies. An intensive care ward is how you need to run your facility. You need analysis, monitoring, and alarming equipment, looking at your facility 24/7. And you also need to build the muscle memory of what a system looks like when it's running correctly. That way, when something doesn't look like it did before, that's what's known as a clue, and you realize things are going in the wrong direction. So usually a change in a digital system is not to your advantage. So you want to be able to have that knowledge of what's right and what's wrong. You need to assign someone or several someones to become a deep diver into your switch configurations, because the people I work with, Cisco, Arista, really sharp people, but they don't live there. They're not going to be there 24/7. So someone in your facility needs to take ownership of knowing a switch configuration inside and out. So what we're really trying to do is have an intelligent conversation with a system integrator and a vendor. We can't just say, I'm not happy, it doesn't work, fix it. You have to help them figure out the problem, because the problem you have may be the first time it's ever existed on the planet, because your specific hardware, your configuration, your workflow is unique. So the problems you're going to have are probably unique. So you need to be the eyes and the ears to work with a vendor or system integrator to say, where are we going? How do we fix it? As far as PTP, I cannot stress this enough. Configure it, get it stable, and then figure out every way you can to creatively break it. What breaks it? What's it look like when it's broken? Does it recover? What do you have to do to get it to recover? And does it ever recover? So you need to get very creative, pull power cords, disconnect the antenna, disconnect whatever, and change configurations to say, aha, this is, if somebody does this wrong, this is what it'll look like. So you're familiar with it. So be very creative. Video engineers, IT engineers, kind of fly through this because the moral of the story here is we need both. In the early days, there was a lot of thought, oh, we can get rid of all of those crotchety video fossils that are obsolete and bring in some smiley faces from the IT world and everything will be okay. Well, that lasted until the first legacy problem happened, which was usually the next morning. Then they had to bring back some video engineers part-time or as consultants or whatever and go from there. So we need both disciplines because IT engineers are about the backbone, the cybersecurity, the switch configuration, network traffic on a grand scale. Where video engineering, it's more about the content. My son's a cybersecurity expert. He really doesn't even know what the content is in some cases. He's a plumber moving content that somebody else worries about. We're video engineers. We have a passion for the audio, the video, the actual production that we're trying to do. And the plumbing system is what it takes to move it around. So it's two different disciplines. We're going to need them. And that's a wonderful thing. So some quick lessons learned that are not IP related, but once again, quality experience is what executives like to track. So always talk in business cases, you know, as far as eyeballs watching, quality of experience issues, closed captioning, for example. Talk in business terms. The language they want to hear is how you always have to position your conversation, or else they don't hear a word you're saying. Thing to keep in mind that UHD is not really 4K. UHD is actually 3840 by 2160. So it's 3.8K. 4K is actually digital cinema. So with contract and lawyers getting involved, oh, you're going to build me a 4K facility. That's 4096 by 2160, and you're delivering me 3840. Well, I think we have a problem here with this contract. Well, you don't want to avoid that. We're not doing 4K. We're doing UHD. So there's bandwidth issues as far as the challenge of doing UHD in the SDI world, because you can have two different ways of doing UHD, square division or two sample interleave. Square division, you have 4 wires, for example, and a quarter of the picture, a quadrant, all the information in a quadrant is on one cable. Or two sample interleave, a 25% of the signal for the entire picture is on one cable. So originally square division people were going to, but if you just lose one feed, a quarter of the picture is gone. You can't ignore that. Where two sample interleave, 25% of the resolution is gone. The picture's still there, but you start having some weird edges on diagonals and whatnot, but the show still goes on. Single link 12 gig SDI, big challenges there because the laws of physics. To get 12 gig SDI signal requires 36 gig of frequency response, well into the RF domain. So radio frequency engineers know exactly what I'm talking about. You have high frequency roll off and reflection issues of a 12 gigabit signal because 36 gig is what you're really trying to pass through it or force through it. So cable lengths are very short, and your whole best practices of cabling need to be pristine. HDR looks wonderful when it's done wonderfully, but the problem is converting it back to SDR. You can have some really strange colors, and that's where most people are watching in SDR. Even though you're doing an HDR, high dynamic range production, coming back to SDR is a given. HDR can be annoying if it's not done right because you're trying to save the specular highlights for the reflections off of somebody's helmet, and you want to have the detail in the blacks. Where HDR can be annoying if you have the brightness of the specular highlights on somebody's white jersey, which looking at the screen eventually becomes fatiguing, and that's not the whole purpose of what we're doing here. Wide color gamut, which is beyond 709 color space, looks great. It's a bigger color palette, but converting it back to 709 doesn't always go that smoothly. So once again, test equipment is your friend. But before we go to some screenshots or some screens I want to share with you, just to get the marketing out of the way, Telestream is now one big happy family. There's been several acquisitions, and Tektronix Video is part of it. So fundamentally, it's the entire workflow from creation to delivery. We have tools for doing things like closed caption insertion, for making a program shorter or longer, time expansion and compression, you name it. We have cloud implementations, we have storage. So anything you need as far as workflow from beginning to end, Telestream, we can have a conversation. Okay, so remaining time that I have here, let's transition out of PowerPoints. I think we've seen enough of those. And look at that. In our Westwood lab up in Massachusetts, up in your neighborhood, I'm remoting out of Northern Virginia to a unit that's up there. So the beauty of the Prism is, which is a waveform monitor that does SDI and IP and PTP. It looks like a shoebox or a pizza box, depends you want an internal screen or not. But think of a waveform monitor that does all the cool stuff we've been doing for decades. Now it does 12 gig SDI, and it does IP analysis and PTP analysis. So we see a picture, we see closed captioning, we have audio, we have a waveform, all the stuff you would expect. So it's a very scalable tool from most casual confidence monitoring to the creative aspects of doing HDR correctly, which is a challenge. And it's a very powerful tool artistically. But what we're going to focus on, since we're all technology people, is the technology that it provides that is unique to the world of IP. So let's start up here at the top right. I can click on any quadrant and it goes full screen. And what we see here, this is all the content that is coming into the Prism up in Massachusetts. And what you see here, you have PTP. You can see your kilobit PTP. You can see megabits for your dash 31 audio, for your dash 30 audio. 40 is your closed captioning, your dash 20, 1.3 gigabits is video. So you can see all the different video attributes and audio attributes in this feed along with PTP. But what you can do is scan to the right and see bit rate, destination IP, excuse me, source IP, destination MAC address, source MAC address. Point I want to make that MAC addresses are very important in the world of SMPTE 2110, especially 2059 PTP. You want to make sure that the MAC address looks familiar for the device you're actually counting on to make the PTP. Because if it's not, it might be a Cisco or Arista clock that actually took over the system to run your facility. So have a cheat sheet of MAC addresses. That way you look at a feed, say, yeah, this is coming from devices that I know, or this is coming from something I have no idea what it is, or shouldn't be doing that in the first place. So what we can see here is all your clock rates, your RTP markers. So 5994, that looks familiar. So obviously we're looking at video. At the top here, keep moving here, we have 2 ports coming in. They're 25 gig with the Reed-Solomon forward error correction, because there's no forward error correction in 10 gigabit interfaces. It's optional in 25 gig because forward error correction is like bubble wrap you put around your content. It gives you extra extra ones and zeros in case there's corruption. It has some extra ones and zeros to make up the difference because it can calculate what ones and zeros are missing and put those in, and you're doing video. You can see there the bar graph at the top is 25 gig interface. We're only putting in 1.3 gig on both ports, our primary and our backup. So everything looks normal there. But let's drill down and let's go to PTP, getting into the fun stuff here. Okay, so what we're looking for, let's go into IP session. And what we see here, layer 1 is we have a lock. It's good to have, let's now over here, click on layer 1. There we go. Layer 1, 25 gig interface. There's actually a signal there. That's our physical layer. Great. That's your ISO 7-layer stack, layer 1, physical layer. Layer 2, do we have lock? Is it a coherent signal? And we have a lock. How many errors does it have? Errored seconds. Low is good. We're in good shape there. Layer 2 metrics. So once again, this is a 7-layer ISO stack. What I like to jump right to is down here, errored frames, oversized packets, undersized, oversized, and errored. If you have congestion in your network, all a switch can do is start dropping packets or mutilating packets because they just don't fit through the pipe at that time because there's burstiness in your system. Burstiness is the problem you're going to have if a network is not properly configured. You want to have smooth, not bursty. Bursty networks start having corruption here, and you can see you have bit error rate and CRC checks. As always, low is good. You can come up here and reset everything, and it restarts counting up again. There we go. Okay, let's move up the ISO stack now. We're going to the video. I didn't want to do that. Let's go here. Get a little bit of a lag here in my VPN connection. Okay, video, layer 3. We're moving up the ISO layer 7-layer stack. Layer 3 is your addresses, your IP addresses. And then layer 4 is your port designation, source and destination for ports. That's your layer 4. Layer 5, we're moving closer to the content, and you can actually see what's happening. This is at the actual video layer we're talking about. Everything looks green and checked, so nothing going on there. Audio should be pretty much the same. Data, pretty much the same. It's just, I want to click that twice, a little bit of a lag here, sorry. And let's go to PTP. This is where it gets interesting. What we see here for PTP is it's locked, great. The time, UTC, deviation, your phase lag. You're trying to get at least 1 microsecond of stability. We're down to nanoseconds. Well, it's a small lab network. On a real network, probably be higher than this, but you don't want it to go above 1 microsecond. So you can see your deviation, your timestamps. Grandmaster ID 080011, that is Tektronix SPG 8000A, which means that is the Grandmaster. If you start seeing a MAC address for a Cisco or Arista, your boundary clock is taken over the system, and that's not good. Steps removed. How much hardware is between the PTP source and where you're monitoring it? Less is always better, because people had the original fantasy way back that you could have 2 signal generators blasting out PTP and perhaps do the entire PTP network for an entire state for a PBS network, for example. Doesn't work. PTP is local area network. It is a campus. It is not a state. So it's not a wide area network implementation. There's problems if you try, but it could be done, but you have to have everything in the network 100% PTP aware. Somebody's out in my driveway, my ring alarm. Okay, my son just visited. Okay, priority 1, priority 2. This is where you're going to be spending the rest of your career trying to figure out how to configure this. Priority 1, this is which device, SPG 8000A, do you want to run your network? And then which one is number 2? Priority 1, if it has power, it's going to be number 1 running the show. The lowest number wins. You can go from 0 to 127. For some reason at the lab, they picked 42. Lower is always better. But really, all this other information, the voting process comes into priority 2. So if everything is even, which SPG 8000A is your primary? If things are uneven, if it loses GPS lock, for example, which unit steps in next? So you want to have everything properly configured so it's not a boundary clock that steps in. You can see where handsets still haven't gotten around to putting a GPS antenna on the roof. You can see here message rates. One of the first places I go with PTP to make sure I'm doing 2059 is 4 to 8 times per second. If I see half a second or 1 second as far as message rate, I'm looking at 1588, which should not be used for video. That's a good old-fashioned PTP for everything else in the industry. If I see high numbers like 50 or 100 messages per second, that's what's known as a band-aid. I was at a facility up near Boston, and I saw numbers 75 or something like that. I said, what is going on here? Oh, this one vendor is not compliant with what everybody else is doing, so we have to send messages 75 times per second or else it won't lock. I go, is anybody addressing that? No. I go, well, they should not be running an entire facility to cover up for a weakness of one device. Nmos. Let's click on Nmos, and I double clicked. Okay, so what Nmos is, it is the days of plug and play. There's a lot of people dragging their feet, which I don't understand, but Nmos, can't remember what the acronym means just because I can't remember what it is, but Nmos is all about registration of a device. You hook it up to your network and the network recognizes it and say, welcome to the network, you're a microphone, you're a camera, and we can take over from there. Because what this is doing is getting to plug and play. We want to be able to drag and drop and configure a network like we've been doing for years. But the challenge is I need some way of doing it automatically. Because right now the world we live in is all about configuration. And when you have thousands of devices with all kinds of port addresses and MAC addresses and IP addresses for source and destinations, typos creep into it and you have chaos in the network. So by going to Nmos, plug and play, a device hooks up, it says, here I am, what IP addresses do you want me to use? And everything works. You don't send video to a microphone. So the world becomes much easier to configure because the whole idea there is to make it easy because in the heat of battle, we don't want to be fiddling around with configuring things. Okay, so where do we go from here? Let me go here and see if I can do this. Let's go here. A little slow here on the response. Go to tiles. And here's you can do your configuration, different streams you can look at as far as your tiles. The point I really want to show you is down here. This is all the different functions you have as far as what you can do with your video. We have good old-fashioned video attributes. We have all the audio and picture, Dolby and whatnot, then our IP layer. And then we have ancillary data drilling down the physical layer. And we have an IP generator and SDI generator. Let's look at the stream timing. That's where I want to go, the remaining minutes that I have here. And let's get out of this. What this is showing me, because in a 7-layer ISO stack, even my days back at IBM on network analysis, anytime there's a timestamp in any of your layers, look at it to see if it's stable, and then compare it to other layers to see if they're in phase or they're wobbling in relationship to each other. So what we're doing here is we're comparing the video timestamp to a PTP offset. You can see your delay, like we're doing, I guess the file is replaying here. But anyway, what you want to see here is your video to RTP, video to PTP. No, it's rescaling, that's what's happening. So that allows you to see what's happening at the video layer. And video to audio offset, lip sync. This is seeing if there's any lip sync errors at the IP layer. It doesn't mean outside of that, the SDI coming in or the SDI going out can be in or out, but saying that at the IP layer, things are being put back correctly and time correlated. So you have audio to RTP timestamps. So once again, you look at your various timestamps to see how things are behaving. And then we go to data, and what we can see here is video to audio, or video to data offset. This is for closed captioning, for example. Data to RTP offset. So it's a good way to see what's happening on your various layers. One more thing I want to jump to is the Prism is the waveform monitor, the analyzer that I've been talking about here. Another product that we have is a layer above that. What it looks at is your entire facility for the health of your video facility in itself, because what you want to have is red light, green light of all your video signals in the 2110 domain. If something is red, you can click on it. Let's click on this and see what happens. I can see what the errors are. There's an Sdp mismatch. This is saying that the header information is not the same as the actual video content because they don't match between the two streams. You want your primary and secondary match, or else you don't have a seamless transition. So it's a good way to see what's happening in a wide view of your facility. Then you can drill down. You can look at your health of your PTP. You can see a lot of things at the layer. This is called the Inspect 2110, which it looks at all your feeds in your facility. Then you can drill down. Once you have a problem child, you click, and it takes you to a Prism, which is what we were looking at earlier, for the deeper analysis into the content. So it's good to see what's happening in your facility wholesale. And then when you want to drill down, you have the tools that can do the drilling. So, well, crowd, that's what I planned to cover. So hopefully you found that of value. And that's what I've learned in the last few years of my travels in the world of IP and PTP. Anybody have any questions, comments, opposing viewpoints? The floor is yours.
Hi, great presentation. I have a question, something you said before. I know your sandbox, you talked about writing right off the Grandmaster. But when you're talking about a bigger in-house network with leaf and spine switches, lots of devices on the end, what is your opinion? You didn't seem to be very favorable about boundary clocking, the pluses and minuses and pitfalls of boundary clocking so that you take some pressure off your Grandmaster.
Yes. And the question is what again?
You said you were pointed to your Prism and you looked at the MAC address and you said, if you're not talking to your Grandmaster, I don't want to paraphrase it, be careful because that means your switch took over and you could be boundary clocking and you didn't go any deeper. My experience is boundary clocking is a necessity in larger networks.
Oh, it is a necessity. I didn't mean to make it sound like it wasn't. Just you have to make sure that your grandmasters that you want to be your grandmaster, like your SPGA 1000A, are configured that they will always be the grandmaster. So by having your priority and priority 1 and priority 2 at a low number, like 1 or 2, that means a boundary clock will be at a higher number. So if you do it the other way, if you have your grandmasters at a higher priority just because you picked a higher number, the lowest number always wins. So if you have a boundary clock that is configured in priority 1, priority 2 lower, it could take over, which you don't want to. The fact is you always want boundary clocks, but you don't want a boundary clock to become the grandmaster and run the entire facility. And it will if you let it, because they're PTP, everybody's willing to jump in and help when it's their turn, but you don't want that to happen.
Thank you. I understand the difference of what you're talking about now. Thank you.
All right, thank you. Glad we clarified that.
Oh,
Yes.
Marty, does Telestream Tektronix have any guidebooks as they used to on, they get some excellent books on various.
Yeah, we have some app notes, but we definitely are doing more videos because people want to watch videos. We have a lot of 5-7 minute videos about various aspects. Go to our website. I'll send you the link, and Marty, you can share it. But yeah, it's on our website for public access. And Mike Waitson, with his British accent, does a better job of explaining it than I can, because the British accent adds about 25 points just for that. But yeah, they're very, very quick, very nicely done, but it helps you understand the basics.
Some of the books on the like Double Diamond and all of that, they were really good. I mean, the videos are great too.
Yep.
But I will check out the website.
Okay. Yes,
Back
Paul.
here, I have a question. I guess I'm suffering a little bit from the flight or fight response, but I look at things like this with a threat assessment value, and assuming that all the technology that you've discussed, and there probably are 30 or 40, maybe 50 variables that all have to be set and running just the right way for your whole system to work.
Yeah.
What are the threats out there, Karl, that cause it to unravel? And is there that risk that once you get it all set up and running, what's the problem? What other evil problems are out there that are going to cause you difficulty?
Yeah. Okay. Good point. In the early days, people were not realizing a non-blocking architecture in the switch. Just because you have 25 gig or 100 gig or 40 gig ports all over the place doesn't mean it can handle that bit rate at all out of all the ports all the time. Because in data is bursty. You're not doing full bandwidth on all the ports all the time. With video, you are. So if you have a blocking architecture, which means the backplane of the actual switch itself can't do it. So as a network is small networks can cover a lot of sins in a design, but networks only get bigger, networks only get more congested. So as a network becomes more taxed, all of a sudden you start having issues with backplane capacity issues. Also, a lot of the trouble with PTP. On a small network, you can get away with a lot of things that aren't really the right way to do it. We start loading up more end devices, that's more traffic, and more traffic always means congestion. And if there's any packets being dropped, corrupted, or instabilities or burstiness, it only gets worse. So networks, if they work when they're small, great. Hasn't proven that it'll always work when you start loading them up. And once again, networks only get more traffic. It's just, there's no way around that. Any network gets more traffic. So I think that's the biggest one. Also, people hooking up devices that aren't really proven to be hooked up. Once again, the sandbox. I mean, extreme example, somebody hooked up a printer on the video network. Well, you don't do that. And I guess they gave it an IP address. That was a conflict. So a printer has no business having an IP address for a video system. So they hooked up the printer, everything fell apart. Disconnected the printer, we're back again. Well, don't hook the printer to the video network. That needs to be on a in-house data network. So also, anytime you're mixing like internet traffic on a video network, early days, big mistake, because internet traffic is bursty. Somebody uploads or downloads. Well, that's competing for your bandwidth that you need constantly for your video, which is a bad thing to do. So I would say that I haven't seen much of that lately. That was an early day because people say, oh, just put everything on the same network. No, you can't do that. It needs to be a fully dedicated video network. And here's a little tidbit I thought of. What I learned in my travels as far as how do you find people that actually have PTP experience? I learned this, a few years ago, I was doing a presentation up at 30 Rock at NBC, and I was going to do a PTP tutorial and a demo. And I realized within about 10 minutes, a guy in the room knew a whole lot more about PTP than I did. And he was a new hire. I go, where did you learn so much about PTP? He goes, this is New York, the financial district. Everybody knows PTP. So if somebody has finance on their resume, they probably get PTP. And something also learned, finance people also understand our business 24/7. There's no downtime. It's got to work because global finance doesn't take time off. So anyway, if you're really desperate to find somebody who knows PTP, finance. But then once again, they need to understand the video part, which is the video is big gigabits and it's got to be smooth all the time. That's one of the lessons learned that I should put into my presentation.
A follow-up question about hardening against hacking or other security issues. You haven't addressed that, and I don't mean to put you on the spot, but does this overly complex system also need an overly complex security capability?
Yes. Yes. If my son was presenting, he could take over for the next half hour. But he said usually the weakness is somebody picks up a thumb drive and shoves it in a slot and corrupts the system. He says you can design a system, best practices, rock solid, but the human element is where it always falls apart. Somebody does something they shouldn't. They go to a website and download. They click on a phishing attempt. That's where it always falls apart. So that's the quandary he deals with. If you get rid of all the people, it's going to be a rock solid system. But no, I don't know much about it as far as how it applies to us, but hopefully you can find people that do, but I do not claim to be a cybersecurity expert. I know enough to know that I know nothing about it.
Thank you.
Hi, Carl. Dave Acker here. A very nice presentation.
Thank you.
I have a question. You mentioned lip sync errors, and I understood that they're detected through the timestamps.
Yes.
And the question is, how are the lip sync errors introduced in the system?
Well, typically they're not. If you have instabilities in your PTP and bursty packets, you'll have a whole lot of other problems other than lip sync. But I would say it's more to prove that the lip sync problem you have is not in the IP layer. It's typically the compression layer or something in the SDI layer. IP, I personally haven't seen it, but you have to be able to prove it because the finger pointing, who's the new kid on the block? On the block, it's the IP. So of course IP is causing my lip sync problem. Usually it's compression layer from my experience.
Is there a way to correct it? Is there automatic ways to do that or no?
Not in the IP layer. I mean, you can do correction in the SDI layer, but not in the IP layer. It is what it is, but usually it's not the problem. If you have problems beyond that, you see other attributes or other symptoms happening before you actually had lip sync problem. I haven't seen lip sync problems with the IP domain in all my years. That's
okay. Thank you.
Yeah.
Okay. Carl, very quickly, this is a future roadmap type question. We're talking about time code, PTP, different timing schemes. What is going to happen downstream when it comes to field production and the introduction of these technologies? So far as, let's say, jam syncing between audio, video recorders, how that gets ported.
Yep. Yes, as far as remote, like with the OB trucks, I'll give you an example, like NEP Game Creek, they are in the bowels of a venue somewhere don't see any daylight. They're not going to get GPS. What they do is a jam sync to NTP because they're only going to be running for a day or two or three. I don't recommend running a 24/7 facility jam syncing to NTP. But jam syncing you can do, and it'll stay accurate because the beauty of what you're buying when you buy Telestream, Tektronix video, is we're an instrument company. And instrument companies for the last 60 some years or 70 years now is all based on being the most stable kid on the block. You can't analyze a signal if you're not more stable than the signal you're trying to analyze. So that is baked into the DNA of our products. So you have a very stable SPG 8000A that will run free run, very stable for a period of time. Let's say you have GPS and you lose GPS. What happens when you regain GPS? What the SPG 8000A is the capability to have a slew rate that is slow within the SMPTE standard for bringing the house reference back into sync with GPS, because GPS is an atomic clock. We're not an atomic clock. We're a very highly stable ovenized oscillator. So you avoid sync shock that way. But I would say in general, if you don't have GPS, you can actually put it this way, you can actually reference your PTP off of a black burst signal. So you can actually, where it is in your network, the grandmaster doesn't necessarily have to be the grandmaster. It can be a slave to your house reference. So you have a facility that's black burst, you want to have an island of PTP. I don't recommend doing it this way, but it has been done. And you can actually reference your PTP off of Blackburst. You can reference it off of NTP, Network Time Protocol. But fundamentally, when in doubt, always have two GPS antennas with avoiding all single points of failure as far as your house reference. So separate coax, separate fiber, separate amplifiers. So that way you have most diversity. So your GPS antennas on a roof spread apart. That way if a snow drift covers one or whatever happens on one end of the roof, it doesn't happen on the other. So you have some resilience in your GPS. But in general, PTP, once it is figured out and once you stress it, it doesn't really become a problem anymore because it's stable and everybody understands the best practices of enabling it. And make sure everybody understands it, because when PTP does go wrong, is it a GPS problem? Is somebody disconnect something? Did something die? Or did somebody add something to the network that probably wasn't really intended to be to the network? It wasn't properly configured. So I don't know if I fully answered your question, but kind of gave you a little bit of a brain dump on that one.
Close enough for now. Karl, good to see you again, and thank you. Good presentation.
Glenn, how you doing? Mr. Axelrod.
Good to see you. Sorry I couldn't join sooner.
Okay, always good to see you. Always good to see all the locals.
Remember that if you miss some of this, it will be within a couple of days posted on our website, the entire meeting.
Yep. And introduce my coworker, Gord Langdon. He is very active in SMPTE, the Toronto section. He is visiting here tonight. So he's a good guy to know. And what Gord and I do is what we're doing here tonight for organizations. Plus, if you have a customer opportunity where they need a tutorial, video 101 or IP 101 or PTP 101, just let us know. That's what we do, because we've definitely realized that the more the industry knows about the technology, the more they realize they need test equipment, and that is good for everybody.
Karl, one other question is, where are we along the transition of SDI now to IP?
I would say we're just getting out of the early adopter sandbox science fair. That we haven't have enough facilities built that are actually noteworthy. And I would say people that are looking into it now had no interest in being the early adopters. We still have people that realize they're never going to go to IP. For example, would be you have a small OB truck where you send out a skeleton crew and you're doing non-major league whatever. SDI works fine. If you have a small facility like a house of worship, SDI is fine. I mean, SDI, everybody knows how to make it work. It's understood. So I would avoid it there. But I would say anyone building a new facility is considering it, because the cost savings isn't there yet. It's going to cost you more. It's going to take longer to do it. But the cost savings is on the other end. Less power. I'm one of the young people I'm mentoring that now works for Cisco, young guy I met through SMPTE. He is doing, and now works for Imagine, I'm sorry. He's doing a paper on the power savings compared to SDI. So for the green initiative and saving power, I don't want to steal any of his thunder, but it's, double digits of % of just power you're saving by going to IP, which means air conditioning load. Also, it's a domino effect when you start saving power. Also, you're saving weight, you're saving space. And I would say, Marty, anybody looking at a new facility should consider it. Unless it's a small facility and budgets are tight and staffing is non-existent, it's going to happen. I mean, there was a fantasy about it being cheaper than SDI. We're not there yet. I mean, once again, and also you need the talent to do it. You need the ability to have the schedule loose enough that you can actually figure the stuff out. Because everybody is still, there aren't any cookie cutter installations that I've seen. Everybody's workflow is unique. Everybody's business model is unique, which means everybody's configuration is unique. Also, how do you plug in all the legacy stuff that you have that you don't want to get rid of? I mean, you're always going to be pulling something out of legacy archives or whatever. You need a way to integrate that in the system. There is no such thing as a fully 2110 facility that I have seen anywhere. They're all still SDI, Blackburst with 2110 IP and PTP. Hybrid facilities everywhere. There were originally plans to build full IP facilities, don't exist.
Well, that led to my next question was what manufacturers are really supporting this big time? I have seen Grass Valley. They put a facility in Emerson College, I believe, some time ago that was.
Yeah, it's everybody. I'm trying to think who wouldn't. It's Lavo, it's Imagine, it's Grass Valley, of course, Evertz. Probably forgetting some, but anybody who plans to be in business for a while is doing it. I mean, I don't see any way around it.
But nothing turnkey yet, with every aspect being.
Turnkey as far as a 2110 installation? No. Nowhere near it. I mean, everyone is a custom build. I mean, I'm working with various system integrators. They have some very sharp people at every project. You really need to understand the workflow. And I guess the challenge is, okay, we're going from SDI to IP, we're going to the cloud. We should really rethink the workflow. We can't just keep the same exact workflow, but change the interface to IP. There's no reason to do that. Now is the chance to say, how do we make this actually more efficient? Of course, there's gonna be some pushback. Everybody likes their workflow and everybody defends it, but it doesn't always make sense business-wise. And especially the remote world that we're living in. The beauty of the Prism, you can remote into it. You can do whatever you're doing. Whatever you saw me do here tonight depends on the connection. Right now I'm VPNing through what is it, Zoom or what Zoom meeting, which is probably not the best way to demonstrate it, but just shows you in less than ideal conditions, I could run a facility. And with all the remote activity in today's situation we have with the virus, a lot of people are getting rid of their older equipment just so they can remote into it and see what's happening. And they say, well, now it's time, we're going to go to IP. So let's buy a Telestream Prism because now's the time. I got the budget and the cost of our equipment really between SDI and IP. It's not that much different. So why not go to something newer? Even if you're not doing IP, it's good to have equipment that can do IP. Anything else?
Thank you, Carl. Any other questions?
Good questions. Good group.
I want to thank you for the presentation. I want to say that my group in IBM, I came from Imagine before, owns a Prism, a master generator for Tektronix, a lot of equipment. We use it. It's important to us. We do have to worry about other things that weren't covered tonight, like people that want to do NDI and other compressed codecs and cheaper networks they want to do on copper. But you know what? It's good stuff and getting better and stronger all the time. And thank you for a great presentation.
Well, yeah, I spent 20 years at IBM.
Carl, if there's any chance of getting the set of slides, I'd love to have them.
I would love to share them. That's what it's all about, sharing. I will send you the file, Marty, and you can share.
Okay.
It will be posted with the video. Thank you, Carl, so much. And thank you for all the other folks who participated from far and field. Thank you again.
All right, guys. Bye.
Thanks
Thank
so
you.
much.
Appreciate your time.
Watch your email for next month's meeting. It'll be the last of the season. Take care.
All right. Bye now, guys.
Bye-bye.
I know.